Alright, so in this video we're going to actually start looking at equations and finding solutions to those equations. So the first part here, just fill in the blanks. To find a solution to a linear equation, that means an equation of a line, so a linear equation, we need to find the value that makes the equation true. So that's really what we're looking for. So when we're given an equation here, so it says for each value of x, determine whether it is a solution to negative 42 equals 7 times the difference of x minus 5. And remember, difference means that we're subtracting. So we're going to go through the table they gave us. We're going to figure out which one of these is the solution. So one of these numbers is going to get us the correct answer here of negative 42. Because we're going to plug it into the side, and that's what we're looking for. We want it to equal 42. So, in this one, I don't know why that says y. That should say x. I need to fix that. That was a typo. That should say x. So we have 3, 8, negative 1, negative 5. So I'm just copying those over from here. So I'm going to go over here and say 7 times, instead of x, because it's 7 times x minus 5, and we're checking, does it equal 42? So basically we're kind of asking a question here. So instead of x, though, I'm going to put in 3 because that's what we're being asked to put in for this first one. So this is, we can do 7 times 3 and then 7 times negative 5, or I can simplify this and go 3 minus 5, well, that's negative 2. And then 7 times negative 2, that gives me negative 14. So if I'm asking the question, does this equal negative 42? No, that is not a solution. It does not equal what I want it to equal. So let's go to 8. So now we're going to use the same equation. We're just going to plug in 8. So I have 7 times 8 minus 5. And now I'm going to go 8 minus 5 is 3. And so 7 times 3, that would give me positive 21. So this is also going to be a no. This is not a solution. All right, 7 times negative 1 minus 5. So now I have negative 1 minus 5. Now remember, and I haven't brought it up again on this one, but you can use algebra tiles on here. Depending on the center you're in, we may have them available to give you the actual algebra tiles, but you can always draw them. So when I'm looking at these, if I have negative 5, 1, 2, 3, 4, 5, like that, and they're all negative, oops, like that. And then really the only part I'm changing, because negative 5 is always negative 5 in this equation, but then I had positive 3, like that, positive, positive, positive. So they canceled, and I had negative 2 left over. So I can see that very quickly with my algebra tiles, because the red represents negative, the yellow represents positive. It's not always red and yellow, but that's a pretty common one that I've seen. So that's why I always tend to use red and yellow when I'm looking at algebra tiles. Same thing when I had the 8. So if I drew 8 of them, 5, 6, 7, 8. So now I have 8. So when I cross these off, all the negatives cross off, and I have a positive 3. So that's where my positive 3 came from. And then with this one, so the last one, I'm going to get rid of all these positives. The one we're working on right now, I have the negative 5, but then I have another negative 1. Well, nothing cancels. I just need to combine them all, and it's going to stay negative. So I'm going to 7 times negative 6 equals negative 42, because 6 times 7 is 42, and since it's a positive times a negative, it's going to be negative. So yes, this one does get me my negative 42 that I was looking for. If I go to the next one here, I have 7 times negative 5 minus 5. So now same thing, I'm going to go back up to my algebra tiles here. I have my negative 5 that I've been working with the whole time, and now I have another negative 5, right? So they're all negatives, nothing cancels out. I'm just going to combine them all. We can think of those literally as like terms. They're not canceling each other, they're just combining to be more negatives. So it's negative 10 equals, and now I have 7 times negative 10, so it's negative 70. So nope, that did not get me what I wanted. So I had no, no, yes, no. So only one of these gave me the solution I was looking for. And that's going to be true for a linear equation. You're not going to find more than one that would give you that same answer, because any other number that I plugged in here is going to get me a different answer. It's not going to get me the same exact answer. All right, if we're looking down here, we have function tables. So a function table, we have an input. So we're inputting something to a function, and that value is the x value. And then we have the output value to a function, and that's the y value. You can think of a function as an input-output machine for numbers. With a machine, when we put something in, we expect a certain result to be output. So this could be any machine that, you can think of a machine. If I put certain items in to make, like, say, a shoe into some kind of machine, every time I put those same items in, as long as I'm putting them in correctly, I should get the exact same shoe out, right? If we had this magic shoe creating machine. So it should always give us the same output results on multiple tries with the same items being put in. So this is the same idea of a function. When we plug in a number, we should get a very specific output every time for that number. But we should get a different output for different numbers, right? So here's my input and output machine. It's just kind of this idea. So we're going to input a number, and then the rule is the equation here. So the rule would be, this is what's going to happen to the numbers. So there's actually two, it's kind of like a double machine here because it's two steps. So first it's going to multiply by -3, because it's y equals 22 minus negative 3x. So I have to do my multiplication first. So it's going to multiply by -3, and then it's going to add 22 to that, because 22 is positive. Remember, this negative belongs to that 3. That's why it went over here with the negative, or with the times -3. So this is what it's going to do to every number we put into the machine. It's going to multiply by -3, then it's going to add 22, and it's going to give us an output. So if we input 1 into our machine here, so I'm inputting 1, it's going to go times 3. So -3 times 1 is -3, and then it's going to add 22. So now I'm going to go 22 minus 3, well, it's going to get me 19, so that's my output. If I put 1 in, I get 19 out. Okay? So now if I input 2, well, it's going to go -3 times 2 first, and then it's going to go 66 minus, 22 minus 6, and that's going to get me 16, right? And then now I'm going to input 4, so I get -3 times 4 is 12, and then I'm going to subtract, and then times 6, -6 times 3 is -18, and when I subtract, I get 4. So each time I put a different number in, I get a different answer out. But if I put 1 in again, I should get 19 again. If I put 2 in again, I should get 16 again. It's a machine. I should get the exact same thing. So these would be the same numbers over here like this. All right, so these are function tables and identifying solutions. So go ahead and go on, Alex, and give it a try.